Hello all. In this video, we are going to learn about the wireless HART communication protocol in Internet of Things, Industrial Internet of Things. So this wireless HART is based on the highway addressable remote transducers. So transducers are the devices which makes use of the sensor signals, processors, and the sensors processed data will be given as the output. So this type of communication is nothing but wireless HART or the highway addressable remote transducer. It is the first international industrial wireless standard and it is based upon the IEEE standard also. This functions with a frequency of 2.4 GHz ISM band using data rate of 250 kb per second. So the data rate is 250 kb. 11 to 26 channels are supported with a gap of 5 MHz between two adjacent channels. The same channel cannot be used consecutively. The main features of this wireless HART exploits IEEE accustomed the direct sequence spread spectrum coding scheme to reduce distortion to increase modulation. This wireless HART node usually follows channel hopping every time when it sends a packet in order to send the data in a sequential manner and also to reduce the loss of packets, addition of packets, uh, insertion of data in the packets. When we are sending a data from one device to another device, error may occur. Error, the types of errors are like insertion of new data, deletion of the previous data, and change in the data. So either extra information can be removed or the information can be changed. So these are the types of errors which usually occurs during communication from input and the between the input and the output. Modulation techniques used are like offset quadrature phase shift keying, OQPSK. So the transmission power is nothing but 10 dBm, adjustable in discrete steps. The features of wireless HART: maximum payload allowed is 127 bytes. It employs time division multiple access that allots distinct time slot of 10 ms for each transmission. TDMA technology is used to provide collision-free and deterministic communications. A sequence of 100 consecutive time slots per second is grouped into a superframe. The slot sizes and the superframe length are always fixed. The other features are like the devices support multiple superframes with differing number of time slots. At least one superframe is always enabled, while additional superframes are enabled and disabled according to the demand of the bandwidth. For any other message, the communication occurs in the slotted time slot and frequency channel, and this types of these types of communication protocol will usually be using star topology or mesh topology. So the next one is a Z-wave communication protocol. This Z-Wave is a low-power radio communication technology. It is mainly used in home automation and security systems. It is usually designed for simpler and cheaper alternative for Zigbee, and also as usual as like Zigbee, this type of Z-Wave communication protocol is also used with medium range of transmission. It operates in the unlicensed part of the industrial, scientific, or medical band, and it usually operates in the range of 908.42 MHz in US and 868.42 MHz in Europe. So Z-Wave uses the mesh network topology to communicate between the devices, and also it can support 232 nodes in the network. So the other important features of Z-Wave are like it offers data rate, data speed, of about 100 kb per second, communication range in the at a distance of 30 meters. The network ID will be in the length of 4 bytes, and the node ID is of length 1 byte. The controller is a central entity which sets up the Z-Wave network and manages other slave devices in the network. I hope you would have learned from the communication protocols in this video. See you in the next video. Until then, it's bye from Radhika.